What's up, everyone? Welcome to my YouTube channel. We will be doing quadratic functions, also known as parabola. So first of all, we have functions of the form y is equal to a x minus p squared plus q. Okay, so now when a is greater than 0, your graph is a smiley face. This is something that we all know. So your graph will look something like that over there, smiley face like that. Then when a is less than 0, your graph is a frown, sad face, or a frown like that. Now let's move on and talk about the parameters of the parabola. Now q shifts the graph up and down, and p shifts the graph left and right. So when q is greater than 0, the graph shifts above the x-axis. Graph shifts above the x-axis, or the graph is above the x-axis, like this one over here. It is above the x-axis, which tells us that q is greater than 0. So q is positive on this one. And then when q is less than 0, the graph shifts below x-axis, or is below the x-axis. So on this one, the graph is below the x-axis, so q is less than 0, so that means q is negative. Okay, let's move on to the parameter p. Parameter p, when p is greater than 0, the graph shifts left. You must catch this. You must have this at the back of your head. You must make sure you know this, because a mistake in this messes up everything, and you're gonna lose a lot of marks in the exam. So you must make sure that you have this at the back of your head. Now when p is less than 0, the graph shifts right. Okay, the graph shifts right. So what does it mean? When it shifts right, then that means it's on the positive side of the x-axis. Then when it's hey, Lord, forgive me for that, when it shifts left, then that means it's on the negative part of the x-axis, on the negative x-axis. Let's move on. Now let's talk about the turning point. So the turning point of y is equal to ax plus p squared plus q is negative p is to q. The reason why we said negative p is to q is because of this sign here, positive sign right there. So what did I say? When p is greater than 0, right? When p is greater than 0, the graph shifts left, and left is the negative side of the x-axis, the negative x-axis. That's why here our coordinates is negative p is to q, because on the graph negative p is to q, p here would be negative because it shifted to the left. It shifted to the left, which is when p is greater than 0, then that graph shifts to the left. So on the graph p will be negative. And by the way, p is the axis of symmetry. Okay, but we'll get there soon. And then here's another illustration here. Turning point of y is equal to a bracket x minus p squared plus q, is p is to q. Okay, so again, this sign, see, it's negative here, and then here it's positive. On the graph it's positive, on the equation it's negative, on the graph it's positive. So when it's negative here, that means it shifts right side of the Cartesian plane is the positive y-axis, right? Positive x-axis. So that's what we're saying here. That's what we're saying here. So this is the turning point of a. Y is equal to a bracket x minus p squared plus q. Let's move on. We have the axis of symmetry next. Axis of symmetry is x is equal to p, e.g. in this equation here, y is equal to a x plus p plus q. The axis of symmetry is x is equal to p, negative p. Sorry, I forgot the squared here. Squared. Okay, so the reason why I'm saying x is equal to p is negative p. Imagine this, you have x plus p, right? Equate this to 0, equate x plus p to 0. If we want x to be the subject of the formula, what will we do? Well, we'll take p to the other side, right? So that's where we're getting x is equal to negative p. Then in this illustration, we have y is equal to a bracket x minus p squared plus q. The axis of symmetry for here is x is equal to p, because once again we mentioned that there's x minus p is equal to 0. We take p to the other side to make x the subject of the formula. Then we have x is equal to p. And then now let's move to the domain and range of a parabola. Okay, so the domain of a parabola is always x is the element of all real numbers. Always. When they ask ask the domain in any question, then you must know that it's x is the element of all real numbers. Simple as that. Moving forward, we have the range. So for this one, I put some examples in order to illustrate, in order to show how the range is written. Okay, so first of all, we have a here. A says y is equal to x minus 4 squared minus 1. The range for this one, for this graph here, is y is greater than or equal to -1. Y is the element of all real numbers. Do not forget to write this, because if you do not write this, then you will not get any marks. So the reason why it's y is greater than or equals to -1 is, well, a here is positive, so hence this sign. A is positive, so a is positive, hence this sign greater than or equal to. So you must look at the sign of a. So here is positive 1. We cannot see it because I have not written it, but it's positive 1. That's why we have greater than or equal to. So y is greater than or equal to -1. Then we don't forget to put y is the element of all real numbers. Then b, we have y is equal to negative x. We have negative x minus 4 squared minus 1. Okay. Oh, sorry about that. Okay, so for b, we have y is equal to negative x minus 4 squared minus 1. Okay, so for this one, a is negative. So since a is negative, our sign is gonna be less than or equal to, because a is negative. So make sure you catch that. So y is less than or equal to q. Our q here is -1. I forgot to mention that here, but I'm mentioning it now. There, q, it's always less than or equal to or greater than or equal to q. So our q here is -1. So it's y is less than or equal to -1. Y is the element of all real numbers. Let's move on. And now for the next part, finding the equation of a parabola. Y is equal to a times x minus x1 times x minus x2. This is called the x-intercept form, and we only use this if we are given the x-intercepts and we have another point on the graph. Then we can use this method. So for example, we have this graph here. We have this x-intercept, which is let me just put it closer here. We have this x-intercept, which is 1:0. Then we also have this x-intercept, which is 5:0. So we have our x-intercepts, 2 of them, because we need 2 of them in order to use this method or this formula. And then we will have another point right there, which is -1:12. Now we can use our formula. So first things first, you write your formula there. Then you're gonna sub your x-intercepts. Your x-intercept, you only take the x, not the y. You don't take the y, you only take the x. So y is equal to a times x minus 1, this one over here, bracket x minus 5, this 5 over there. And then we sub the point -1:12 into this equation. So since this is an, it's okay, so this is an x, this is a y, right? So when we sub this point into this equation, okay, let's not forget that there's a y there. So this is x, this is y. Okay, even on the yeah, you understand. I don't want to complicate things by explaining too much. So yeah, you sub the point. You know what happens when you sub the point. This is the x, this is y. You sub it, then you have this 12 here on the y. It replaces y is equal to a times -1. Negative 1. This replaces the x. -1 squared minus 6a times -1 plus 5a. Then you simplify. So this into that, this into that. Then you add everything. You add all the like terms. Then it adds up to 12a. Then you divide both sides by 12, and your a is 1. Therefore, your equation would be, and there you have it. Your equation is y is equal to x squared minus 6x plus 5. Now let's move on to the second form, which is the turning point form. So we have y is equal to a times x minus p squared plus q. So we use this method if we have the turning point and another point given. For example, on this graph, they've given us the turning point. Apologies for drawing it like that. It's not on the correct position, but you get me. This is the turning point, okay? So this is the turning point, -3 is to 1. And then this is the other point we have on the graph, which is 1 is to 5. So now we can use our formula, our turning point form, which is y is equal to a bracket x minus p squared plus q. Then we sub turning point, -3 is to 1 first. Then we have y is equal to a times x plus 3 squared plus 1. This is what we have now after we've subbed the turning point coordinates. Then now we sub point 1 is to 5, the other point that we have here, 1 is to 5. We sub it into this equation right here. We sub it into this equation. Then we will have 5 is equal to a times 1 plus 3 squared plus 1. And then you distribute, you simplify. You'll be left with a 16a or a16. When you take this one to the other side, it will be 5 minus 1, like so, and then it's equals to a16 or 16a. Divide both sides by 16, and your a will be a quarter. Then therefore your equation will be y is equal to quarter. Then your equation would be y is equal to a quarter x plus 3 squared plus 1. And that is it for now. Let's move on to the next part. Okay, so now we've moved on. We're on writing the equation of a shifted parabola. When your parabola is shifted m units to the right, we replace x with x minus m. So wherever there's x on your the equation of your parabola, you're gonna replace it with x minus m. M being the units that they tell you that. For example, they shifted 4 units to the right, so you're gonna replace m there with 4. M units, 4 units. You get the idea? I hope so. I hope we're on the same page. Let's move on. Shifted m units to the left, you replace x with x plus m. Shifted n units down, same thing, you replace y with y plus n. Shifted n units up, you replace y with y minus n. Now for reflection, if it's reflected about the x-axis, you're gonna put a negative on the y or g of x or f of x, because it's the same as y. F of x is the same as y, so you can put a negative there if it's reflected about the x-axis. But don't forget to divide by that negative, so that you are left with a positive at the end, because your equation cannot be negative, it must be positive. Okay, I hope you understand each other. The subject of the formula, which is the y, must be positive, it cannot be left negative. Okay, now turning point, we move on. Turning point, if the equation is in the form of y is equal to ax plus bx plus c, we use x is equal to negative b over 2a. This is from the quadratic formula. We use that to find the x value of the turning point. Then we sub the answer we get into the equation of the parabola, which is y is equal to ax plus b, y is equal to ax plus bx plus c. we sub that x value that we get into the equation of the parabola to find the corresponding y value of the turning point. I hope we're on the same page. Let's move on. Points of intersection. Okay, points of intersection. If given two graphs, e.g. g of x and f of x, to find our points of intersection, we equate the graphs g of x. We equate the graphs, so that would be g of x equal to f of x. So if we're given two graphs, for example g of x and f of x, to find their points of intersection, we equate the graphs. Okay, so g of x, okay, so g of x, we make it equal to f of x. So then after that we solve for x. Okay, we solve for x, we sub the x value or values into one of the equations, g of x or f of x, to find the corresponding y values of the thingy, the point of intersection or points of intersection. And that is about it.